Welcome to The Explainer. Today, we're diving into some fascinating research from the journal World Water Policy that introduces a new framework for thinking about one of our planet's biggest challenges, water stress.
So, let's just kick things off with a big question, especially for anyone in water planning or policy. Are we trying to solve 21st century water problems with 20th century tools? It's a serious question we really need to ask.
Okay, so here's what we're going to cover. First, we'll talk about why our old tools are falling short. Then we'll introduce this new Dynamic Water Stress Framework, or DWS. We'll peek under the hood at its economic engine, see what makes it so different, and then, this is the cool part, we'll see it in action with a real-world case study. And stick around, because at the end, we'll reveal the #1 thing we can do to make a difference.
All right, first up, the limits of our old tools. The big problem is that we've been relying on these static snapshots, like a single photograph trying to capture a moving target. And water stress? It's anything but static. It's constantly changing. Okay, this table breaks it down perfectly. You've got the classic Falcon Mark index. Super simple, but it misses a ton of detail. Then you have more advanced stuff like the Aqueduct Atlas from the World Resources Institute, which is great, but it doesn't quite connect the dots to economic productivity. And here's the real kicker. None of them let you really test out policies, to ask what if and see the results. But look over at that last column. For the DWS, it's designed to tick all those boxes. That's a game changer.
And that's exactly where this new research comes in with the solution, the Dynamic Water Stress Index, or DWS for short. You can think of it as a new kind of model, one that's built from the ground up to connect our economy directly to the reality of our water supply.
So here's the big idea, right? The DWS framework isn't just counting gallons in and gallons out. No, it starts way earlier. It looks at the real-world ingredients of an economy, things like capital, labor, and other resources to figure out its potential economic output. Then, and this is the clever part, it figures out how thirsty that economy would be to reach its potential. Finally, it compares that thirst against what the water supply is actually going to look like, factoring in climate change.
Okay, so let's pop the hood and see what's powering this thing. What makes this model's engine so different from what we've seen before? All right, at the core of this model is something called a modified Cobb-Douglas production function. I know, it sounds a little academic, but the idea is actually pretty simple. Just think of it like an economic recipe for each part of the economy: agriculture, industry, services. It calculates the potential economic output, what economists call gross value added, or GVA. So for agriculture, the recipe needs capital, labor, and of course land. For industry, it's capital, labor, and intermediate inputs, think raw materials. And for services, it's all about human capital, people's skills. And the really important part? It figures all this out before even thinking about water limits.
Okay, so you have this potential economic output. How do you know how much water that actually translates to? Well, there's a bridge, and it's called water use efficiency, or WEU. It's a really straightforward metric. How much economic value, in dollars, do you get for every cubic meter of water you use? This isn't just some random number either. It aligns with the UN Sustainable Development Goals. It's what lets the model connect the dots and figure out exactly how much water each sector would need to hit its full economic stride.
So it all boils down to this really clear 4-step process. Step 1, figure out the potential economic output for each sector. Step 2, use that water use efficiency metric to turn that dollar amount into a volume of water. Step 3, look at the other side of the equation, the water supply, and adjust it based on what climate models are telling us is coming. The paper uses a standard IPCC scenario called RCP 4.5. And finally, Step 4, compare the demand to the supply. And boom, you've got your Dynamic Water Stress Index. And it's this whole process that gives the DWS its superpower, really. It's not just about measuring what's happening now. It's a tool for looking ahead, for being proactive, and for actually simulating policy. So, if you're a water planner, what does this actually mean for you? Well, it means you get 4 huge advantages. 1, you can break down the problem by sector and see exactly who is using what. 2, you can start to balance those big economic goals with what the water supply can actually handle. 3, you're building future climate change right into your plans. And 4, and this is the big one, you can finally start playing what if. What if we invest in better irrigation? What if we focus on improving skills in the service sector? You can test these ideas out and see the impact on water stress before you commit any real resources.
Okay, that's the theory. But how does it actually work in the real world? Well, the paper gives us a perfect case study: Lebanon, a country facing some really tough water and economic pressures.
So looking at the baseline year, 2019, This is before some of the country's more recent troubles. The DWS model calculated a stress level of 88.5%. Now that number puts Lebanon squarely in the high-stress category. We're talking about demand getting dangerously close to an unsustainable point.
But the projection for 2035 is where it gets really alarming. Even if you assume they make some decent improvements in tech and efficiency, the model projects the water stress will hit 113.6%. That pushes the country way past high stress and into critical stress.
So what does critical stress actually mean? It means you've crossed a major tipping point. Anytime that number goes over 100%, it means your economy's total demand for water is projected to be more than your entire sustainable renewable supply. That's a recipe for overpumping groundwater, not having enough water to go around, and putting your whole economy at risk.
And this is where you can really see the power of this DWS tool. You don't just get that one big national number. You can drill down. The model gives you a stress index for each sector. And what it shows for Lebanon in 2035 is just staggering. The projection is that every single major economic sector, agriculture, industry, and services, will be in a state of critical water stress, each one demanding more water than its fair share of what's available.
Okay, so when you're looking at a forecast that grim, the big question is, what do you do? Where do you even start? This is where the model's sensitivity analysis gives us a clear, powerful answer.
It turns out the single most powerful thing you can do, the biggest lever you can pull, isn't building more dams or even trying to slow down the economy. Nope. By a long shot, the key is to aggressively improve water use efficiency, getting more bang for every drop across the board.
The model basically lays out two very different futures. On one path, if efficiency stays the same and the economy grows, it's a disaster. Water stress could shoot up to a shocking 178%. But look at the other path. If you get ambitious about improving that water use efficiency, you could actually bring that stress level back down just below that critical 100% mark, all while still allowing for moderate economic growth. So let's wrap this up. What are the big things to take away here? First, this DWS framework is a huge step up from static snapshots. It's dynamic and forward-looking. Second, it creates a direct, undeniable link between economic activity and water demand. Third, it's a fantastic diagnostic tool, letting you pinpoint exactly where the problems are. And finally, and maybe most importantly, it shows us that improving our water use efficiency is absolutely the most critical lever we have for a sustainable future. And that really leaves us with one final thought, especially for all the planners and researchers out there. If you had a tool like this, a tool that lets you test drive your water policies before you launch them, what would you do differently? What new ideas would you explore to build a truly water-secure future?